I'm Dr. Mahammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about computer network subject, in which the topic is a transport services. That means the outcome of the transport services. That means the transport layer services. Transport layer, it is a fourth layer of the OSI reference model. Generally, these are the transport of the service. The transport layer of the service, it is a very reliable data delivery can be performed from one application process to the another application process. So, in a computer network subject, this service, transport of the service now, which giving the guarantee the data arrives in the correct order, exact data, the correct data can be delivered without errors, which give the assurance. This is the transport of the service now, which is giving the assurance, and with the proper flow of the control to managing the rate of the data transmissions between the two applications. That means one application is running one mission, another application is running another mission. To this, the two other missions now, reliability, which is the performing the reliability and proper proper flow control can be done without errors. Now, data transmissions can be done from between the two devices. Here is the transport layer. So it is a fourth layer of the OSI reference model. See, from the top, it is a fourth layer. From the bottom now, if you see, physical layer, data link layer, network layer, the transport layer. Transport layer is a fourth layer. The main role of the transport layer is to providing the communication service. Here is, which is providing the communication. This is the main goal of this transport layer, which is providing the communication between the two other devices with help of these the protocols. Now, generally it is using the protocols are TCP and UDP protocol. By using the TCP UDP protocol now, which provide the other communications directly to the application process running on a different host. That means now the running on a different host or two systems now, the applications are running. So in these are the applications now, which is the providing the other service, which is providing the communication service direct to this the application of the process. The transport layer of the protocols are very that should be implemented in at the end of the system, but not in the network of the routers. That means generally end-to-end the systems. That means one host is connected at one end here, another host is connected at another end here. So these are the transport layer of the protocols. That means the transport layer of the protocols are generally we can use the TCP protocol and UDP protocol. These TCP and UDP protocols are implemented at the end systems, but not in the networking routers. At the system side only. At the system side, source system side and destination system side. The source and destination systems now, we can call it as a end systems. At that systems level only, these are the transport layer services can be provided. That will be implemented the other services. See, here the computer networks now, which is providing more than the one other protocols to the network of the applications. For example, now if you TCP UDP, generally we are utilizing in a transport layer. So with help of this the TCP and UDP other protocols, so we can provide the other services. These are the two transport layer protocols. Now, which is providing the different other services in a transport layer over the internet. Which provide the services to network layer. So below the transport layer now, in OSI reference model, network layer is below the transport layer, which is providing the services, different services which is providing. TCP, if it is suppose if you are going to using the TCP now, which is provide the services as a connection oriented services, and UDP now, which is provide the services as a that is a connectionless services. These are the two services now providing to the network layer, which is below to the transport layer. Generally, all the transport layers, which is the providing the multiplexing and demultiplexing can be these are the services can be provided at the source other side and at the destination side. At the source side now, what it is doing now, which is providing the multiplexing at source side, and at the destination side now, which is providing the demultiplexing. Multiplexing means now many inputs, combine the many inputs now producing the single the output. Demultiplexing now combining, that means is the reverse of this the multiplexing. It is also provide these are the these are the transport layer services now, which is also provide the other services, so such as the reliable data transfer. Reliable data transfer means, so that means here exact data without the loss. Now whatever the data you are transferring from the sender the source side, from the sender side, now same the exact data without loss or without errors, now that will be reaches to the destinations. That is and the bandwidth the guarantees now, which is giving the bandwidth should be the guaranteed bandwidth can be given, and also the delay guarantees the guarantees that will be provided. So these are all these the services. These are all the these services can be provided by the transport layer. And here, see, this is a two-way the communication purpose. This is the transport layer now, which is providing this two-way communication. So that means now the data link layer. Here is the data link layer, the second layer. So which is below the network layer. This data link layer providing the service within the single the network. Within a single the network. So that means now, while the transport layer provides services across the internet work, which is made up of the many networks. Here, transport layer, which is using the many networks, and data link layer, which is providing the service using the single network. So this is the main difference between the single, the main difference between the data link layer and internet layer. That means this is the transport of the layer. So whenever utilizing this for data transfer, for data link layer now, which is using the single network. By using the single network now, the data transparency can be done. If you use the transport layer now, many networks now, which is using the many networks. So here is now two-way communication. If you see network layer, the transport layer now, which is using the many networks, application layer, network layer. So two layers which is using here. So the communication which is provided to the application. That means so application so any at end user level. Generally this application layer now, which is a view at the end user level, end user can able to see this whatever information now sent by the sender. So that information is received. That means here once at the receiver side, at the receiver side the approach is a bottom up approach. At the sender side now, the approach is a top down approach. That means now the information is coming from the transport to the physical layer and then transmitted to the destination. The destination now receives the information, demultiplex the information. Whatever the information is receiving, that information can be demultiplexed. Once it is demultiplexed here, now within the top down, in a bottom up approach now, the transport layer now, which is providing the other services to the application layer. The application layer here, which is having the number of users, multiple users now. So multiple users, user 1, user 2, up to n number of users now, they can able to access the applications. They can able to share the information. They can able to see the information at application layer level. This level now they can able to see. This is a two-way communication. Here the transport layer services generally provided while communicating the information between the two devices are end-to-end delivery. That means the information can be delivered to one other system to the another system. End-to-end means source to destination. So here the addressing can be done. Addressing can be done means now with help of these other IP addresses. With help of this IP address now, for exact device. Here with the addressing, the transport layer service now, which is providing the addressing now. With this the addressing, that means the IP addressing now, the content and data, the information can be delivered to the exact the destination, the device now, whatever the device, the IP addresses now we are going to sending the respective exact device, the information can be sent at transferable. Reliable delivery. Reliable delivery means now write exact the content. Correct the content can be delivered, whatever the content transferring from the source mission. So that same content can be, so reliable delivery, that means now whatever the content now we are going to the transferring from the source mission now, same content can be delivered to the other destination. Here is a flow control. Flow the control means now the data over, suppose if is over this the network now, large amount of data now we are going to transferring. So that large amount of the data will be leading to the congestions, now it will be overloaded. So that overloaded the conditions now that can be removed with the help of this the flow the controlling mechanism. And the multiplexing, which is a transport layer of the service now, many inputs can be combined and as a single output. So these are the services can be provided with the help of this the transport the layer. See, end to end the delivery. That means one system to another system. That is a source system to the destination system. The services can be provided. The transport layer now, which is transmitting the entire message. Here is the whatever that other message now we are going to transferring. The entire message can be transferred to the destination. That particular destination now, that message can be transferred. That means now, which ensures the end-to-end delivery. Here, end-to-end the delivery of the entire other message from the source station to the destination station. That means reliable delivery. Reliable delivery, that's accurate data transmissions can be done with the help of this in a reliable other delivery. The transport layer now, which is providing the reliable services to the destination other devices. That means accurate data, whatever the data destinations are expecting, that the expected the data can be delivered to the destination devices by retransmitting. If any data is lost, if any data is not reachable to the destination here, that will be retransmitted. The lost data packets or damaged data packets or unreachable other data packets can be retransmitted. So these are the services now we can call it as a reliable other services. The reliable delivery has 4 aspects now, that is a error control, sequence control, loss control and duplicate control. So these are the 4 services now which is having reliable delivery. Reliable delivery means now which is error control, sequence control, and loss control, and duplication control. So which is reliable delivery, again which is having the 4 categories: error control, sequence control, loss control and duplicate control. So these are all the aspects of the reliability. So error control, generally the primary role of this reliability is error control. This is the error control. That means error control means now in this type of this other reliability, that means now no other transmissions will be the 100% error-free delivery. So this is the error control. Therefore, now the transport layer, this what it is doing now, which is using these other protocols, TCP and UDP protocols. By using these other protocols, now which is transferring the error-free other messages. By this is a error control now we can call it as. So it is designed to providing the error-free transmissions. These transport layers are designed to transmitting the error-free other transmissions with help of the TCP and UDP other protocols are designed for transmitting the data. Sequence other control. Generally. So the second aspect of the reliability. So this is a reliability we can achieve with the help of the sequence of other control. Sequence of control generally implemented at the transport layer at the source side and destination side. Both the side now, this sequencing other control can be implemented. Why? Because now whatever the data, whatever the packets now we are transferring from the sender to the receiver, those data packets can be transferred in a sequence. In a sequencing way, the data packets can be transferred. Packet 1, packet 2, packet 3, packet 4 up to dash n number of other packets now we can able to transfer from sender to the receiver. On the sending end, the transport layer is now which is responsible for the ensuring that the packets are received from the upper layers that can be used by the lower layer. Here generally at the sender side, which is receiving the packets above the transport layer. Above the other transport layer, so that is from this the session layer. Now the packets can be received and delivering to the whatever the packets are received from the session layer now, so which is delivered to the network layer. Network layer is below the transport layer, so that means now up layer to the down layer. Now the sender sending the transmissions. Application to the physical layer, the transmissions can be done. That is a top-down approach, which is a sender is the following for transmitting the information or for sending the information. Here, once that information, whatever the information we are going to transferring, once if it is reaches to the other destination here, that other destination which is following the which is following the bottom-up approach. So that means the data packets are transferred. That means transferred from the network layer to the transport layer, and the transport layer to the above layer, the session layer, presentation layer, application layer. Now up to the above layer now, the data packets can be transferred to the up to the application layer. At this the application level, now end user can able to utilizing the other services. He can able to view the other data at the application level at the these are the destination of the missions. Many users now they can able to share the other data at the application level. So this is a sequencing control. Here, loss control. Loss control is a third aspect of the these reliability service. Now the transport layer now which is ensures that all the fragments of these other transmissions which is arriving at the destination, not some of them. So not some of them means now whatever the whatever the data packets now we are going to transferring from the sender mission, all the data packets that will be transferred to the other destination. So not from the all the packets, no, not some of the packets can be transferred. Now whatever the packets now we are going to transferring, all the packets that can be transferred to the other destinations. So on the sending side now, all the other fragments of the transmissions. Here, all the other fragments of these transmissions are given the sequence of the numbers by the transport layer, which is by giving the sequence number to the transport layer now. So sending the all the other fragment of the other data. So these are the sequence the number now which allow the receivers. The transport layer now which is identifying with this the sequence number, whatever the packets now we are going to transferring from the sender with by attaching this the sequence number now at the other destination at the receiver now which is identifying all the sequence number. If any sequence numbers are missing now, easily if the sequence number is not followed, if it is not received by the receiver now, which is identified, so the packet is missed. That means missing segments or missing other packets easily can be identified. So with this sequence, that is a loss. Now that means data loss can be controlled by assigning this the sequence numbers also. So this is about the loss control. And next the duplication control. Duplication control is nothing but a fourth other aspect of the reliability. Here, the transport layer now which is giving the no duplicate data is transmitted to the other destination, which is giving the guarantee. No duplicate data can be transmitted to the destination. That is no duplication is nothing but a reliability. No duplication transmission is nothing but it is a reliability. Here is now sequence numbers are used. Here also now we are duplication for that now sequence numbers are using 1, 2, 3, 4 up to n number of sequence numbers can be used to identifying the lost packets. Whatever packets are missing or lost packets. Similarly now which the receivers allows to identifying and discarding the duplicate segments or duplicate packets. If same sequence numbers are received, if the destination of the receiver, if it is received the same the sequencing number, two or three more the same sequencing number, now which is identifying the duplicate packets and discarding that the duplicate packets, same sequencing. Whatever the packets having the same sequencing number, so immediately now one of these packet sequencing number of the packet will be discarded. So these are all the reliability services. And flow control. Flow control. So it is used to preventing the sender from the overloading the receiver. Flow control means now whenever the large data is transferring over this internet, over this the networking, or whenever now we are going to transfer the bulk amount of data over this internet, generally the overloading will happen. That means the congestions will be arise. So if the receiver is overloaded, that means now bulk amount of data is received by the receiver. By the receiver here, the bulk amount of data is received. Now it will be the overloaded. So that means now receiver now, if it is overloaded, discarding the packets and asking for the retransmission of the packets to the sender, sending the acknowledgement to the sender. The packets now, whatever the packets are transmitting by the sender here, so it will be overloaded again. Again is transmitted to retransmit this other packet according to the network other capacity. Whatever the network now having this other capacity, that much of this other capacity packets need to other transfer. This increases network other congestions. Here is not reducing the system or the performance. Network other congestion now, this overloading, retransmitting, now which is reducing the network of the congestions. So by retransmitting now, the retransmitting this data packets now, the performance, the system performance and network performance can be improved. Here, that's why this is the network layer now which is having the responsibility for flow control mechanism by assigning or by reducing the overloading, the content overloading. Now this flow control can be controlling the flow of the data between the sender and receiver. Here is for that now which is using the technology sliding window protocol technology. Flow control can be done by the help of the sliding window or the protocol technology, sliding wise. That means the data can be transmitted from sender to the receiver in terms of this the sliding in the small packets. That is divided into small piece of data, small piece of the packets and transmitting. That makes the data transmissions are more efficient. If it is a large amount of data is divided into small piece of packets now, it is a more efficient. As well as it controls the flow of data. Flow of data now it should be controlled here, so that now the receiver does not become the overloaded. If it is controlling now, does not become the overloaded now. Sliding window protocols, it is a byte oriented. So sliding window protocols means now in terms of sliding the informations, the data, whatever the packets are transferring from the sender to the receiver. So the packets can be arranged in a sliding window. And if you are going to arrange the sliding window, this transmission is more efficient, the transmission, more effective transmissions rather than the frame orientation. Frame or the orientation now it is very efficient. And multiplexing. Transport layer using the multiplexing to improving the transmission efficiency. So that means now multiplexing, what we are doing, more number of inputs you are using and producing the single output. That is a more inputs, single output. Multiplexing can occur in a two-way communications. That means upward, which is having the two types of this multiplexing. One is a upward multiplexing and a downward multiplexing. Upward multiplexing means now multiple transport layers. Multiple transport layer connection to the same network connection. Same network connection now, multiple transport layer that will be connected to the same network connection. Here is upward multiplexing. That means multiple transport layers are utilizing that will be connected to the same network. That is a one virtual circuit. Here is now, if you see, so this is a layer 1 stock, layer 2, layer 3, number of 3 layers, layering stocks now that will be connected to the single virtual circuit. That is a upward, that is a transport of the layer, the upward here. Now downward multiplexing. Downward multiplexing means here one transport layer connection uses the multiple network connection. That means here one transport layer, so which is connecting to the multiple networks. So this is a downward the multiplexing. Generally the downward multiplexing now, which is allowed by the transport layer now, which is splitting a connection. So whatever the connections are giving from the transport layer now, which is splitting the connections among the several paths to improving the throughput. Several paths now, whenever going to several paths, throughput can be improved. Here, this type of this is the multiplexing. That is a downward multiplexing and upward multiplexing. So it is used when the network having the low or slow capacity. The capacity is whenever the network the capacity is a very low or the speed is very low, very slow speed now, then only these multiplexing as the technology can be used. By using this multiplexing technology effectively and efficiently transferring the data from the source and source to receiver. Here is for the transport the services now. The textbook is A4 is on data communication and networking, and yes, the Tenenbaum the computer the networks. So 5th edition. So these two are the textbook for the transport the services. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.